Hi there and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video we're going to be working on exercise number 6 in lesson 6 of exponential growth and decay functions. So it says, today a billionaire is worth $100 billion. The billionaire gives 15% of her money to charity every year. Set up an equation to model the total money remaining m of t after t years. So what we have here is an example of a decay formula because the billionaire is giving away 15% of her money every year. So giving away means you're subtracting from the total amount you have. So let's remember our general form of an exponential decay formula is y equals a times 1 minus r to the power t. But of course, we know our new variables now are going to be m of t and t. So let's change out that y with an m of t. And let's see what information we know. Do we know our initial amount? And we sure do. We know that our initial amount is going to be $100 billion. So we're going to have $100 billion right there. And then we're going to have 1 minus our rate at which we're decreasing by, and that's going to be 15%. But again, we want to change that to a decimal, so that's going to be 0.15. So it's going to be 1 minus 0.15 to the power of t. That's part A. There's our equation that we could use to model the total amount of money remaining after t years. Then we get a little bit more specific in part B, where it says how much of this $100 billion will remain to the nearest cent after 10 years if she does not make any additional deposits or withdrawals. So just working with this amount right here, how much money will remain after 10 years? So we're going to have to do m of 10 is equal to $100 billion times 1 minus 0.15 to the power of 10. What we're going to do there is we're going to go to our calculator, and you're going to enter in 100 and make sure you put the correct amount of zeros. We have 1, 2, 3 for 1,000, 1, 2, 3 for million, and 1, 2, 3 for billion. And then we're going to multiply that by 1 minus 0.15, and that's going to be raised to the power of 10. And when you press on enter right there, you're going to get a number that looks like this. And if you're using the same kind of calculator as I am, this is not going to give us our value to the nearest cent. We need to have more decimal places for that. So how can we get more decimal places in our calculator? Well, what we're going to do instead is we're going to try to use our y equals option, and we're going to put that same equation into y equals. And I have it all the way down to the 10th power over here. You could choose to do to the 10th power, or what I'm going to actually do right here is I'm just going to raise it to the x power. And I'm just going to have it raised to the x power, and that will give me every year. So I pull up my table of values, and in my table of values, it gives me the amount after every year. And if I look after 10 years, it says 2e to the 10th. That's even worse than the value I was getting over here on my home screen. But a little trick that we know about this calculator is if we go over to the right and highlight that number, oh, there it is. Now we see the decimals all the way to the nearest cent. So we do, in fact, have an exact number right here of 19,687,440,434 and 7 cents. So again, I'm going to have to go back and forth a couple of times here. And if I find my, where is my, oh, there we go. Okay, so we have m of 10 will be 19 billion there it is, 19 billion 687,440,000 434 and 7 cents. 434 and 7 cents. So this would be the amount remaining in the account after 10 years to the nearest cent. So not only did we set up an exponential decay formula in this problem and then find an amount remaining after 10 years, but we learned a new trick with the calculator if you're using that kind of calculator when you solve. Otherwise, if you're using a web browser and any of those calculators as well, you probably would have gotten amount that was more exact than what was shown in that calculator. But anyway, I hope this video is helpful in solving exercise number 6 here. And if it was, please give it a thumbs up to let me know that it was helpful. Otherwise, you're ready for exercise number 7 now, which deals with another exponential decay type of formula. Thank you for watching.